असतो मा सद्गमय तमसो मा ज्योतिर्गमय मृत्योर्मा अमृतंगमय। ॐ शान्ति शान्ति शान्तिः।
Namaste. In this video, I want to discuss about acceleration. In fact, acceleration is rate of change of velocity, how quickly the velocity changes. So that is what we call as acceleration. In fact, in acceleration also, there is uniform acceleration, variable acceleration. And in fact, when the acceleration decreases the velocity, we may also call it as the retardation. So, three things are there. First, we learn one by one. So, in this, we write acceleration, there, uniform acceleration, and variable. Usually, if we say acceleration, we always imagine there's an increase in velocity. But there is the acceleration which decreases the velocity also. For example, when we apply the brakes on the car, moving car or something like that, the velocity goes on decreasing. The acceleration is in the opposite direction. That is, it tries to decrease the velocity. So that is what we call as retardation. In fact, so acceleration is rate of change of velocity, and there are two things, variable and uniform. Uniform means, as we said in case of uniform velocity, in the same manner, equal changes in velocity in equal intervals of time. That is uniform acceleration. Variable means in this second it may be something, in the next second it may be different, the direction or the magnitude. That is what we call as variable acceleration. But basically, in 11th and 12th, we consider only the uniform accelerated situations. So we constrain ourselves to the uniformly accelerated motion. And now we try to visualize what happens when an object is accelerated. Say, a car is accelerated. So, what is the how the distances are covered when a car is accelerated? Simply observe. I write a picture of a car moving on a road. Say, and this is the car, and it is at rest, u0, initial velocity. Then it moves with, say, a 1 meter per second square acceleration. Now, after 1 second, it traveled, say, it acquired some velocity, it traveled, say, 1 meter. We say simply 1 meter. After next second, that is t equals 1 second here. In the t equals 2 seconds, as the velocity is more now, it covers more distance. So it might have covered 3 meters there from t equals 1 to t equals 2 seconds. And that is, the car will be here after 1 second, and car will be here after 3 seconds, say, sorry, 2 seconds. It goes on. Observe, the distances covered goes on increasing. Goes on increasing. We can also write one more. The t equals 3 seconds, the car may be here much farther than that. Say t equals, this distance may be 5 meter there. It covered more distance, and as time increases, because velocity goes on increasing. So this is the situation what we need to think of. Say, as soon as we hear the word acceleration, we must we must be able to see these sort of things in our mind. The velocity goes on increasing. That's right. Distances covered goes on increasing. In the first second, it is smaller, second larger, third second, much larger. It goes on happening. So, this is what we mean by the visualization, what we require for acceleration. This is for the acceleration, that means which increases the velocity. Now we'll try for retardation, uniform retardation. I write that. Just observe. I write the uniform retardation. The distances covered are smaller and smaller as the distance, as the time elapses, because velocity goes on decreasing till it comes to rest. So that is what is the thing. I just, without any scale, I write simply in the first second, it might have traveled a large distance. In the second, it might have traveled a small distance there. In the third second, even still smaller, like this. Observe the gaps. The gaps are reducing. Finally, it comes to rest. The distances are becoming smaller and smaller. Finally, it comes to rest. So, this is about retardation. This is for retardation. That is where the velocity goes on decreasing. It is for increasing velocity. That is acceleration, we simply say. It implies there's an increase in velocity. Retardation, where the decrease in velocity happens like this. Main thing is, as acceleration is there, the velocity goes on increasing and the distances covered in each second or in each unit of time goes on increasing. In case of retardation, a velocity goes on decreasing, the distances covered goes on becoming smaller and smaller. Finally, the object may come to rest. So these two are the two important things. What we can get out of these two figures. This is for the acceleration and this is for the retardation. I have written without any scale, simply I have written it like this. So what we must know, what we must get in our mind is this picture. As soon as we say acceleration, this one, retardation, this one. So this is the thing what I need to say in this video. In the coming videos, we'll learn about the graphs of moving objects, position time graph, velocity time graph. For different situations, we need to learn to write. So there, I conclude this